Students, today we're doing clouds, and you're going to actually make a cloud in a jar. And there's a lot of ways to make a cloud in a jar. And this one involves matches, so if you're teaching younger kids, you might need parents to help, or you might want to do all the match lighting. But with older kids, it's probably okay to use the matches. There are other ones where you use a 2-liter bottle and you squeeze it, but this is the one that I prefer. You can see my little cauldron here, where I have some interesting things going on. But right here, I want you to direct your attention to these 3 beakers. Now, I have water in all 3 of its forms right in front of me. And water is such an amazing compound because it's the only compound I'm aware of where it exists in nature in all 3 states: solid, liquid, and gas. So if we look here, we see that we have solid water, chunks of water. H2O in the solid form. But it's still 2 hydrogens and 1 oxygen, and that's what makes this water. You can also see that there's some droplets on the outside of this beaker already. It's a very humid day today. There's a lot of moisture in the air. This is liquid water. And this exists in rivers and so on. We see this on mountains, we see this in snow, we see this in a lot of different places. So this would be water vapor, gas, water gas, okay? We can't see water that's in the gaseous form. So what are clouds made of? Are they made out of solid water, liquid water, or water vapor? Not too sure about that. So let's see what we can come up with here. Now, we're going to make a cloud in a jar. You need some hot water, and we have directions that say fill a jar with hot water, 3/4 full, let it sit, and then we are going to just need a little bit. I'm going to pour the excess in here. We're going to leave some of the hot water at the bottom. Okay? Leave some of the hot water at the bottom. Then what we're going to do is we're going to light a match. And we're going to just stick it in here, and then we're going to blow it out. And we're going to let some of that smoke go in there. And then what we're going to do is we're going to put some cold water on top. And what we should be able to see is something going on inside. And if you can see that actual motion of the air is in this kind of motion. We call that convection. We've made a convection current, and we've also made clouds. We can see it. Could we see water vapor? No. Can we see clouds? Yes. So are clouds made out of water vapor? No. They're not made out of water vapor. Everyone thinks clouds are a gas. What are they? What can we see? Can we see liquid water? Can we see solid water? Yes. But we cannot see water vapor. So clouds cannot be made out of water vapor. Now you can see that cloud is going around, up and down. We've made a cloud in the jar. There are 3 things that we need to make a cloud in a jar. We need cold, we need hot, and we need something for the water to grab onto. Water on this, there are, on the outside of this beaker, there's water droplets. This jar is doing the same job, providing the same job as the smoke did in here. They are what we call condensation nuclei. So in order for clouds to form, we need hot and cold. We need a temperature difference. Okay? We need interaction between the hot and the cold. And we also need some kind of surface for the water vapor to condense onto. That is what we need in order to form a cloud. Now, I want you to try this at home. You don't have to have a mason jar. Everyone has ice, hot water, and matches. I just did it putting hot on the bottom, cold on the top, and lighting a match and getting smoke in here. I want you to try 2 variations. Maybe you'll not use a match and do everything else the same. Maybe you'll put cold on the bottom and hot on the top. So you're going to do 2 variations on this idea and see if you get a cloud to form. And we're going to see what is the real key to making clouds. Because there are days where there's no clouds in the sky, and there are days where the whole sky is cloudy. And there are certain things that must happen in order for clouds to form. So that's going to be the top of your assignment sheet. Why do clouds form? You're going to do 2 other experiments changing 1 item. So that's going to be the top part. Now, if we look at the second part, where it says extend, we are going to talk about this at this part right now. I'm going to tell you that the molecules that are in these 3 beakers are moving at different speeds. The water molecules in solid water are basically just vibrating back and forth. They're not moving very fast. Think of them like a 90-year-old with a walker. Okay? That's about how fast they are. Liquid water molecules move at about the rate of an average college student going from class to class on campus. Medium. Gas water molecules move like a bus full of 8th graders that just pulled up at Cedar Point, and you open the door and say, "See you in 6 hours." These things move so fast. So you've got a table down here on the extend part of your assignment where you are talking about a process where we go from a gas, which is like the 8th graders at Cedar Point, to a liquid, which is like you guys walking around campus. What is the name when water vapor turns into liquid? What has to happen? We call that condensation. So you would put condensation here. Now, the water itself goes from the kids at Cedar Point to you. Does the water gain energy or lose energy? If it's going from very fast to medium, the water itself loses energy. Now, energy cannot be created or destroyed. That energy had to go somewhere. The atmosphere then gains energy. Right now we have some hurricanes going in right over the Gulf of Mexico, about to get New Orleans. As that hurricane is going over the warm waters of the Gulf of Mexico, huge amounts of condensation are taking place. The energy is going from the water to the atmosphere. This is what is fueling this storm. When we get these really severe thunderstorms, the fuel comes from water condensing, releases energy to the atmosphere. So our unit on weather, we're going to be looking at this energy in the atmosphere. That's what is responsible for a lot of our weather. Look at the second one, a liquid to a gas. When you have a puddle, what does it do? It turns into a gas. What is the word we use for that? It's down here, evaporation. When we go from a liquid to a solid, we put it in the what in our refrigerator, the top part. Solid to a liquid, we put ice out. Eventually, what's going to happen to this? It's already happening. Okay, that's melting. Gas to a solid, that is called deposition. Okay, the process is deposition. We're going from the gas, the kid's running around, to grandma with her walker. When deposition occurs, water loses a lot of energy. The atmosphere gains. Deposition is like when you go out to your car in the winter and there are beautiful crystals on your car. We call that frost. Deposition has occurred. It's gone directly from the gas to the solid, and you know that it didn't. When you go out to your car in the winter and there's just streaks of ice on your windshield, then you know deposition didn't occur. It just froze. Freezing occurred. But when there's beautiful, intricate little patterns, you know that deposition occurred. And then when we go from the solid directly to the gas, we have what's called sublimation. So let's go. This is, dry ice is simply solid carbon dioxide. So it's not a dangerous substance, it's just carbon dioxide. And you can go to Meijer and you can buy, this is like a little, half-pound pack, or I don't even know how much was in here. I love, for Halloween, I love having a pot on my porch with a big chunk of dry ice in it and making all this nice little, you're going from the solid to the gas, and you see that sublimation. So you need to fill out this chart and talk about each one. Will the water gain or lose energy? Now, in our evaluate part, you know that melting involves going from a solid to a liquid, condensation, a gas to a liquid, sublimation is the solid to the gas, evaporation, the liquid to the gas. You need, and there's many answers to this question, so you need to figure out, well, one of these doesn't involve a liquid. That would make that one different. Or one of these goes 2 steps from a solid all the way to the gas. So you're going to circle one of these and tell why it doesn't fit the pattern. The next thing you're going to do is draw a diagram showing that circulation of air that we saw in our cloud in a jar. Okay, so this is your complete why do clouds form, and it's a really fun lesson to do at home. And make sure you do those 2 things, you vary 2 things. Try to make the cloud in a jar first, and then change 2 things just to make sure that you're successful making the cloud in the jar.